This is section 4.6. We're going to prove that triangles are congruent by angle, side angle, and angle, angle, side. Now, you should already be familiar with these naming principles. So 2A's mean two pairs of congruent angles. The S means a pair of congruent sides, and the location of that S is important. So the congruent sides here are included. That means they're in between the congruent angles. And the congruent sides here are non-included. That means they will not be in between the two pairs of congruent angles. Both of these arrangements prove that two triangles are congruent. So if you have these parts in two triangles, they have to be the same size and shape. And that's what this postulate 21 tells you. It's the angle side angle postulate. Don't read it as ASA or ASA. It's angle side angle. And here's what it looks like. You got your two pairs of congruent angles, you got a pair of congruent sides, and they're included. They're in between the congruent angles. These two triangles must be the same size and shape. It's impossible for them to be different. Here's two triangles. We want to prove that they're congruent, and they give you some information that you can use. The first thing I notice in the picture, angle E is congruent to angle C. That's a pair of congruent parts. I'm allowed to use that. We know that's true. Now, the other thing they tell you, it's a longer statement. Segment AD is a perpendicular bisector of segment CE. I'm separating those two statements because they're really different from each other. This is a congruent statement. This is a statement about two segments, and they're using a term. So if a segment AD is a perpendicular bisector of segment CE, that means some things. Perpendicular means you're going to have right angles, obviously. And bisector means those two segments are going to be congruent. This is the segment that's getting bisected, so those are the segments that are congruent. Now, when you have perpendicular lines, you end up with right angles in those spots. So if you look at these triangles right now, it's kind of important to know where you're going before you start writing things in a proof. Because sometimes when you have right angles, it's important to say that they're congruent. And sometimes when you have right angles, it's important to say that the triangles are right triangles, depending on which congruence theorem or postulate you're going to use. Well, looking at these marks, these triangles are congruent. They're going to be congruent by angle, side angle. So we need to say that these right angles are congruent angles, is what we need to say. Okay? So let's make some sense of this perpendicular bisector stuff. What is a perpendicular bisector? Well, a perpendicular bisector gives you right angles. Okay, so angle ABE and angle CBD are right angles. We know that. That's what a perpendicular bisector is. Now, also, you know that there's some congruent segments because a segment is getting bisected. Segment CB is definitely congruent to another segment. Just make sure you watch the order. It's got to be segment EB. If you're not sure from the picture, look at the statement up here. Segment CB is congruent to segment EB. Okay, so we're kind of caught up with the marks that we have on the picture. Now remember, we're going to say they're congruent by angle, side angle, but before you do that, you can't use angle, side angle with right angles. You have to say that those two angles are congruent. So angle ABE is congruent to angle DBC. And again, watch the order. If you're not sure what goes with what, look at the congruent statement up here. This tells you what goes with what. How do you know two right angles are congruent? That's your right. What is going on here? Right angle congruence theorem. That's theorem 2.3, if you don't remember. So now, those are right angles, but I'm going to mark them as congruent as well, just so I know in my picture that I have two congruent triangles by angle side angle. Triangle CBD is congruent to triangle EBA. Angle side angle.